Food is one of the few systems we interact with every single day without ever seeing how it actually works. You read a label and you assume that everything behind that label has been figured out. A significant percentage of global fish stocks are either fully exploited or overexploited. Farm salmon, naturally gray. So to meet consumer expectations, compounds like astaxanthin are added to the feed to produce that familiar pink color. Under current production models, the carbon footprint of lab-grown meat could be significantly higher than conventional beef. Ocean systems, changing environments, foreign systems control production, lab-grown systems manufacture biology, and plant-based systems reconstructed inputs. Now ask a simple question. What happens when food is no longer tied to ecosystems? Most people don't question the food system, not because they studied it and trust it, but because they've never been given a reason to look at it closely. Food is one of the few systems we interact with every single day without ever seeing how it actually works. You go to a store, you pick something up, you read a label, and you assume that everything behind that label has been figured out, tested, controlled, regulated, but that assumption is not based on understanding. It's based on distance. Distance from the production, distance from the sourcing, distance from the systems that actually create what ends up on your plate. And that distance matters because the further you are from something, the easier it is to simplify it. And that's exactly what's happened with the global food system. It's been simplified into narratives that are easy to accept. We're told the oceans are being overfished. We're told we need alternatives like lab-grown meat. We're told modern agriculture is simply scaling up to feed a growing population, and none of those statements are false, but they're incomplete. And incomplete information is where systems hide complexity, because when you reduce something complex into simple explanation, you remove the need to question it. Now here's the problem. The food system today is not just complex, it's engineered. Not in the sense that everything is artificial, but in the sense that every part of it has been optimized for yield, for consistency, for scalability. And once you start optimizing something at that level, you introduce trade-offs, not always visible, not always immediate, but always present. And those trade-offs don't show up on labels, they don't show up in marketing, they don't show up in the way food is presented to consumers. Because what consumers see is the final product, not the process. And the process is where everything happens. And here's where this becomes important. Because once you look at the systems from that perspective, you stop asking surface level questions. You stop asking, is this food healthy? And you start asking, what had to happen for this food to exist in this form? And that's the question that changes everything, because it forces you to look backwards through production, through processing, through sourcing, through environmental conditions, through systems that are rarely discussed. And once you do that, patterns start to appear, not isolated issues, not one-off problems, patterns across completely different categories of food. Now, this is where we need to be very clear. This is not a story about one product. This is not a story about one company. This is not even a story about one type of food. It's a story about how modern food systems operate at scale, because scale is the defining factor here. Small systems behave different. Local systems behave different. But once something becomes global, everything changes. Supply changes, stretching across countries, production becomes centralized, processing becomes standardized, and the margin for variability shrinks because variability reduces efficiency, and efficiency is the priority. Now think about what that means. A system optimized for efficiency. What gets deprioritized, not intentionally, but structurally, what becomes secondary? Now we start to see the tension. Because the food system has to do two things at the same time. It has to produce massive amounts of foods consistently at a global scale, and it has to maintain safety, quality, and nutritional value. And those goals do not always align perfectly. Now here's where people assume something. They assume that regulation bridges that gap, that if something is unsafe, it won't be allowed. But regulation doesn't eliminate complexity, it manages it. And managing something is not the same as fully understanding it, because regulation is built on models, assumptions, acceptable thresholds, and those models are based on what can be measured, not always on everything that exists. We're building a foundation here, not a conclusion, a framework. The food system is global, highly optimized, complex, and partially understood. And that combination matters because systems like this don't fail in obvious ways. They don't collapse, they don't stop working, they continue functioning while carrying hidden variables that only become visible under certain conditions: outbreaks, contamination events, environmental shifts. And those events are not the systems breaking, they are the systems being revealed. Now, here's the part most people miss, because when something like that happens, the focus goes to the event, the outbreak, the contamination, the recall, and the system responds, it corrects, it adjusts, and then everything returns to normal. But what rarely gets examined is the structure that allowed that event to happen in the first place. And that's where the real investigation begins. Because when you start looking at the system itself, instead of just the outcomes, you begin to see something very different. Not a collection of unrelated problems, but a consistent pattern across completely different types of food: fish, meat, plant-based alternatives, lab-grown products, different categories, different technologies, same underlying structure, scale, control, optimization, and trade-offs. Once you recognize that pattern, you can't look at any one category in isolation because they're all connected by the same system. So instead of starting with a conclusion, we start with something much simpler. We take a look at one category at a time. We look at what's actually happening, what the data shows, what the system requires, and what isn't being discussed. And we follow that pattern wherever it leads. And when you do that, you don't just see problems, you see the structure behind them. So let's start with something familiar, something most people think they already understand: the ocean. Because the story we've been told about fish is only part of what's really happening. The ocean is usually where this conversation begins, not because it's the most complex part of the food system, but because it's the easiest to simplify. You've heard the message before: overfishing, declining fish populations, ecosystems under pressure, and those things are real according to the Food and Agriculture Organization of the United Nations. A significant percentage of global fish stocks are either fully exploited or overexploited. That part of the story is not controversial, but it's also not complete. Because while attention has been focused on how many fish are being removed from the ocean, something else has been happening at the same time. Something less visible, something harder to measure. The quality of the ocean itself has been changing. Not in a way that's easy to see, but in a way that's measurable. Over the past several decades, microplastics have become a persistent part of marine environments. Not just large pieces of debris, but microscopic particles, often less than 5 millimeters in size, in many cases much smaller, invisible to the human eye, but not invisible to the ecosystem. These particles come from multiple sources: breakdown of larger plastics, synthetic textiles, industrial processes, consumer products, and once they enter the ocean, they don't disappear. They fragment, they persist, and they distribute. Studies have detected microplastics in surface waters, deep sea sediments, and even in remote regions far from direct human activity, which means this is not localized contamination, it's systemic. And here's where it becomes relevant to food. Because microplastics do not just exist in the water, they interact with the living organisms. Plankton ingest them, not because they're selective, but because at that scale, particles are indistinguishable from the real food. And plankton is not insignificant, it sits at the base of the marine food chain, which means what enters plankton has the potential to move upward. Small fish consume plankton, large fish consume small fish, predatory species sit at the top, and at every level, material moves. This is what's known as trophic transfer, the movement of substances through levels of a food chain. And while trophic transfers has always existed, what's moving through the system has changed. Now add another layer. Because microplastics are not inert, they don't just pass through the environment unchanged, they can interact with other compounds. They can absorb persistent organic pollutants, heavy metals, chemicals already present in the marine environment. In simple terms, they can act as carriers transporting substances through biological systems. Now we stay precise. The exact health implications of microplastics in humans are still being studied. There's no single definitive conclusion that applies universally, but detection is not hypothetical. Microplastics have been identified in seafood and marine organisms and in environments that are part of the human food chain. That is documented. This is where the narrative begins to shift. The conversation about seafood is often framed around quantity. How much is being caught? How much remains? But that frame leaves something out: quality. What is the fish carrying when it reaches human consumption? Because if the environment has changed, then the organisms within that environment are also part of that change. Now here's where it becomes more complex, because not all species are affected equally and not all environments are the same. Filter feeders like shellfish are particularly relevant because they process large volumes of water, which increases exposure to whatever is suspended in that water. Multiple studies have detected microplastics in mussels, oysters, and other filter feeding species. But this is not limited to shellfish. Fish species have also been found to contain microplastics, sometimes in digestive systems, in their tissues. Now again, we stay grounded. Detection does not automatically mean harm. It does not confirm exposure, and exposure is the first step in any risk pathway. Now layer behavior on top of that, because human consumption patterns matter. Seafood is often consumed regularly, sometimes multiple times per week, and in certain diets, even more frequently, which means exposure, if present, is not a single event. It becomes repetitive. Now connect that to what we established earlier: systems that scale, supply chains that expand, and products that move farther from their origin, which means their consumer is multiple steps removed from the source environment. Now here's the key question. At what point does environmental change become part of the food system itself? Because if contamination exists in the environment and the environment produces the food, then the boundary between the two disappears. Now we go one layer deeper, because this is not just about what's present, it's about what can be measured. And measurement is where things become complicated. Detecting microplastics requires specific methods: sampling, filtration, microscopy, spectroscopy, and those methods are still being refined, which means what we detect is based on how we measure, and what we measure is based on what we look for. So the absence of detection does not necessarily mean absence of presence. It can also reflect limitations in measurement. Now we stay careful. We are not suggesting hidden contamination without evidence. We're recognizing the limits of current tools, and those limits matter in complex systems. Now step back again, because this is where the story becomes less about fish and more about structure. The ocean is not isolated. It is part of the global system, and the global system includes industrial production, waste streams, chemical use, material persistence, all of which interact with marine environments. So when we talk about seafood, we're not just talking about fish. We're talking about a system that includes environmental inputs, biological processes, and human consumption. Now bring it back to the consumer, because this is where perception diverges from reality. Seafood is often seen as clean, natural, healthy, and in many cases it is. But those qualities are assumed to be stable, unchanging, independent of the environment. And that assumption is where the disconnect happens, because the environment is not static, it changes. And those changes are not always visible at the surface. Now here's the important distinction. This is not an argument against seafood. It's not a claim that all fish are contaminated. That would be inaccurate. What this is an acknowledgement that the system producing seafood is connected to an environment that has changed, and those changes are measurable. And if the environment has changed, then what we pull from it has also changed. That's not an opinion. That's a consequence. Because once that connection is clear, the next question becomes unavoidable. If the environment has changed and seafood is part of that environment, what happens when we try to control it? What happens when we move from wild systems to controlled systems? Because that's where the story goes next. Not back to nature, but deeper into design. At some point, the ocean stops being the solution and starts becoming the problem, not because fish disappear, but because consistency disappears. Wild systems are unpredictable. Fish move, populations shift, conditions change, and that unpredictability doesn't work at scale. So the systems adapt. It doesn't return to balance. It creates control. And that's where aquaculture comes in. Fish farming. Now that is where perception and reality begin to separate, because when most people see salmon in a grocery store, they assume something simple: that it came from the ocean, that it lived naturally, that it reflects the environment it came from, but in most cases it doesn't. The majority of salmon consumed globally today is farmed, not wild. And that distinction matters, because farmed salmon is not just fish raised in water. It is a controlled production system. Now start with labeling, because this is where confusion begins. Walk into a store and look at the labels. You'll see terms like Atlantic salmon, wild caught Pacific salmon, and they sound similar, but they're not the same. Wild Atlantic salmon populations have been significantly depleted, and in many regions, commercial fishing is restricted or even prohibited. So when you see Atlantic salmon in a grocery store, it is almost always farmed. But the label doesn't say farmed, it says Atlantic. because that refers to the species, not the method of production. Now, this is not illegal, it follows labeling rules, but it creates an assumption. That assumption is rarely correct. Now, look at how farm salmon are actually raised. They are typically kept in large net pens, high density enclosures in coastal waters, thousands of fish, confined space, and that density changes everything because when you concentrate animals at that level, you create conditions that don't exist in the wild. Disease pressure increases, parasites spread more easily, stress levels change, and those factors require intervention. But now we got to be precise. Aquaculture is not inherently unsafe, but it is fundamentally different. It is managed, controlled, and optimized. Now look at the feed, because this is where another layer appears. Wild salmon eat a natural diet, smaller fish, crustaceans, marine organisms. That diet contributes to their nutritional profile and their color. Farm salmon do not have access to that same ecosystem, so their feed is formulated, a combination of fish meal, plant proteins, oils, and supplements, designed to promote growth and consistency. Now here's where something subtle but important happens: color. Wild salmon are naturally pink because of the carotenoids in their diet. Farm salmon, naturally gray. So to meet consumer expectations, compounds like astaxanthin are added to the feed to produce that familiar pink color. Now, astaxanthin itself is not inherently harmful. It is used in aquaculture globally, but that's not the point. The point is what it represents. The product is being adjusted to match expectation, not necessarily origin. Now step back, because what looks natural is being engineered. Now add another layer: antibiotics, because density creates risk. When large numbers of fish are kept together, the potential for disease increases, and in many aquaculture systems, antibiotics have been used to manage that risk. Now, regulations vary by region. Some countries have stricter controls, others less so, but the use of antibiotics in aquaculture have been documented, and that matters for two reasons. One, residues, which are regulated and monitored. Two, antibiotic resistance, which is a broader public health concern. Now we stay grounded. Not all farm fish contains antibiotic residues. Testing exists, standards exist, but the system itself relies on interventions that do not exist in wild environments. Now add environmental impact, because fish farming doesn't happen in isolation. Waste, feed, byproducts, they don't disappear. They enter surrounding waters, which can affect local ecosystems. Now again, this is not a claim that all aquaculture is harmful. It is an acknowledgement that controlled systems create external effects. Now bring everything together. Wild fish, unpredictable, variable, environmentally driven. Farm fish, controlled, standardized, system driven. And when you move from one to the other, you don't just change the source, you change the entire structure. Now return to the consumer, because this is where the disconnect matters the most. People choose salmon for a reason: health, omega-3s, protein, and in many cases, those benefits still exist. But the assumption behind them, that the product reflects a natural system, is not always accurate. Now ask a simple question. When you buy salmon, what are you actually buying? A fish or a system? Because at this scale, those two things are not separate. Once you see how the system controls something that was once natural, the next step becomes easier to understand. We don't just control the environment, we start to replace it. And that's where the story goes next. Not into farming, but into something entirely different. The attempt to create food without the original system at all. At some point, controlling nature stops being enough, because even controlled systems have limits. Farm fish still depend on ecosystems, feed inputs, water conditions, environmental variables that can be fully eliminated. So the next step in the system is not control, it's removal. Remove the ecosystem entirely and replace it with something else. This is where lab-grown meat enters the conversation. Often described as the future of food, cleaner, more sustainable, more ethical, and on the surface it makes sense. If traditional agriculture creates environmental pressure, why not remove the animal entirely? Why not grow meat directly? Now this is where we slow down, because most people hear lab-grown meat and imagine something simple: cells growing into meat, a cleaner version of the same product. But the reality is more complex. This is not farming, it is biomanufacturing. The process starts with animal cells. These cells are placed into a growth medium, a nutrient-rich solution designed to support cell proliferation. They are then grown in a controlled environment. Bioreactors, machines designed to maintain precise conditions. temperature, oxygen levels, nutrient flow, everything is controlled. And as cells multiply, they are structured into tissue using scaffolding materials that allow them to form something resembling meat. Now step back, because this is not just a different method, it is a completely different system, one that operates more like pharmaceutical production than agriculture. And that difference matters because pharmaceutical grade processes come with specific requirements: high purity inputs, strict contamination control, continuous monitoring, and most importantly, energy. Now bring in the data. A study from the University of California, Davis, examined the environmental impact of lab-grown meat production. And what it found was not what most people expected. Under current production models, the carbon footprint of lab-grown meat could be significantly higher than conventional beef. In some scenarios, 4 to 25 times higher. But let's pause. That contradicts the core narrative. This technology is often presented as environmentally superior, but that assumption depends on how it is produced. And the production at scale requires highly refined growth media, energy-intensive processes, constant system control, and that changes the equation. Now we stay grounded. Lab-grown meat is still developing, production methods are evolving, future efficiencies may change these numbers, but the current data introduces uncertainty. And that uncertainty matters because it challenges the assumption that new automatically means better, which means the solution being offered may carry its own set of trade-offs that aren't part of the pitch. Now go deeper, because the environment question is only one part. The other part is inputs. What exactly is used to grow these cells? Growth media historically included components derived from animal serum, though companies are working to replace these with synthetic or plant-based alternatives, and that transition is ongoing. Now again, we stay precise. This is not a fixed system. It is still being built, still being optimized, still being tested, but that also means it is not fully understood at scale. Now step back again, because we're not evaluating a product, we're evaluating a direction, a shift from raising animals to manufacturing tissue. And that shift changes everything. Now bring back the original assumption that this is more natural or closer to nature because it removes animal suffering. But in reality, this is not a return to nature, it is a complete departure from it. Now that doesn't make it inherently bad, but it does make it fundamentally different. And that difference requires understanding. Now ask a simple question. What happens when food is no longer tied to ecosystems? Because ecosystems provide constraints, limits, feedback loops, natural balances, and when you remove those constraints, you gain controls, but you also remove boundaries. Now this is where the system becomes harder to evaluate, because traditional food systems can be observed, measured in fields, in oceans and farms, but biomanufacturing systems operate differently. They are closed, controlled, technical, and less visible to the public. Now layer that into larger patterns, ocean systems changing, farming systems controlling, and now manufacturing systems replacing, and bring it back to the consumer, because this is where perception matters. Lab-grown meat is presented as a solution, a response to the problems of traditional agriculture, but it may solve some of those problems, but it also introduces new variables, new dependencies, new uncertainties, and those are not always visible in the narrative. Now we come to a critical point, because this is where most conversations stop. At comparison, traditional versus alternative, better versus worse. But the real question is not which is better, it's what kind of system we are building. Because once you move into the fully controlled production, you are no longer adjusting nature, you are replacing it. And replacement changes responsibility. Now we move forward, because lab-grown meat is not the only alternative system. At the same time, another category has expanded rapidly, one that appears simpler on the surface, but becomes just as complex when you look closer: plant-based foods. And this is where the pattern continues, not away from complexity, but deeper into it. At this point, the pattern should feel familiar. A problem is identified, a solution is introduced, and that solution is presented as cleaner, simpler, better. And that's exactly how plant-based foods have been positioned. As an alternative, a correction, a move back towards something more natural. But when you look at how these products are actually made, the story becomes more complicated, because plant-based foods at scale are not whole foods. They are formulations. Now that distinction matters, because a whole food is something you recognize: a plant, a grain, a legume, something that exists in its original form. A formulation is different. It is built, constructed from components that have been separated, processed, and recombined. And that's how many plant-based products are created. Start with the base ingredients: soy, peas, wheat, common crops, and they are not used as is, They are broken down, processed to isolate specific components, protein, oil, fiber, each extracted separately. Now here's where the process becomes important. Because extraction at scale requires efficiency, and efficiency often involves chemical processes, one of the most commonly used solvents in food processes is hexane, a petroleum-derived compound used to separate oils and proteins from plant materials. Now we stay precise. Hexane used in food processing is regulated, residual levels are controlled, and final products are required to meet safety standards. But that doesn't change the process itself. The fact is that extraction relies on industrial solvents. Now step back, because this is where perception and reality diverge. Plant-based products are marketed as clean, natural, simple, but the process behind them is anything but simple. It is industrial, layered, highly controlled. Now move to the next step, reconstruction. Because once components are extracted, they don't stay separate. They are recombined. Protein isolates are mixed with oils, binders, flavoring systems, texturizers, all designed to replicate something else, meat, not just nutritionally, but structurally, texture, mouthfeel, cooking, behavior. Now this is where the category becomes very specific. These products are not trying to be plants, they are trying to behave like meat. And that requires engineering, not just cooking. Now layer in another factor, additives. Because when you build a product from isolated components, you lose certain properties, stability, flavor, complexity, binding, and those properties are reintroduced through additives, stabilizers, emulsifiers, flavor enhancers. Now again, we stay grounded. These ingredients are approved, they are regulated, but their presence reflects something important. This is not a simple food. It is a designed product. Now add another layer, allergens, because many plant-based products rely on common allergenic proteins, soy, wheat, in some cases pea protein. And while these are safe for most people, they can trigger reactions in others, including cross-reactivity in sensitive individuals. Now step back again, because we're building something very specific, not a criticism, a structure. Plant-based foods at scale are highly processed, component-based, reconstructed, and dependent on industrial methods. Now compare that to the narrative. Clean, simple, natural, and you start to see the gap. Now here's where it becomes more important, because these products are not occasional, they're integrated into daily diets, consumed regularly, sometimes as primary protein sources, which means any assumptions about their simplicity becomes part of daily behavior. Now ask a simple question. What does plant-based actually mean? Does it mean minimally processed? Does it mean whole? Or does it simply mean the original source is a plant? Because those are not the same thing. And that distinction is rarely made clear. Now bring back the larger pattern. Ocean systems, changing environments, foreign systems, control production, lab-grown systems, manufactured biology, and plant-based systems, reconstructed inputs. Different approaches, same direction, more control, more processing, more distance from original forms. Now bring it back to the consumer again, because this is where everything converges. People are making choices, trying to eat better, trying to reduce impact, trying to move toward what they believe is healthier, and those intentions matter. But those decisions are based on information, and if the information is simplified, the decisions are simplified also. Now we move forward because we've looked at alternatives, plant-based, lab-grown, but the original system hasn't disappeared. It's still there, still operating, still scaling, and still carrying its own set of trade-offs. And that's where we go next, back to the system that never stopped, just changed shape. Up to this point, we've looked at alternatives, fish, farming, lab-grown meat, plant-based systems, different categories, different technologies, but they all connect back to one thing, the original system, industrial meat production. Because no matter how many alternatives are introduced, this system hasn't disappeared. It has actually expanded. It has changed. And this is where perception becomes a problem once again. Because when most people think about farming, they picture something small, fields, animals, open space, and that image doesn't reflect how most meat is actually produced today. Modern meat production is industrial, large-scale, highly controlled, designed for efficiency. Now start with density, because this is where everything begins. When you increase the number of animals in a confined space, you increase output, but you also increase pressure, disease pressure, stress, transmission, conditions that don't exist at the level in natural environments. And once those conditions exist, intervention becomes necessary. Now, this is where antibiotics enter the system. Antibiotics are used in livestock production, sometimes to treat disease, sometimes to prevent it, especially in high-density environments. Now we stay precise. Not all farms use antibiotics the same way. Regulations vary by country. Standards exist. But the use of antibiotics in animal agriculture is well documented, and that creates a larger issue because many of the antibiotics used in livestock are also used in human medicine. Classes like tetracyclines, penicillins. Now, why that matters? Because repeated use of antibiotics in any system can contribute to resistance. And antibiotic resistance is not a theoretical concern. It has been identified by the World Health Organization as a major global health challenge. Now again, we stay grounded. We're not saying all meat causes resistance. We're saying the system contributes to the conditions where resistance can develop. And that distinction matters. Now, add another layer, waste. Because animals produce waste, and at small scale, that waste is manageable. It returns to the soil. It integrates into the environment. But at industrial scale, the volume changes. Large operations produce massive quantities of manure, stored in lagoons, managed in concentrated areas, and that waste contains more than just organic material. It contains bacteria, nutrients, residues from antibiotics. Now, what happens to that waste? In many cases, it is contained, but not perfectly. Runoff can occur, leaching can occur, and when that happens, it affects surrounding environments, water systems, soil quality, air. Now step back, because this is not a single issue, it's a system level effect. Now add proximity, because these operations are not always isolated. Communities exist nearby, and in some regions, residents have reported odor, airborne particulates, water concerns, and now we stay precise. These are reported experiences, not universal outcomes, but they reflect something important. What happens inside the system does not always stay inside the system. Now connect this to everything we've already seen. Ocean systems affected by environmental changes, farm fish, controlled environments, lab-grown meat manufacturing systems, plant-based reconstruction inputs, and industrial meat scaled biological production. Different systems, same direction, more control, more efficiency, more output, but with that more complexity. Now here's the part that matters most, because this is where everything converges. The food system is not failing, it is doing exactly what it was designed to do. Produce more, faster, at scale, and it does that extremely well. But every system optimized for one outcome creates trade-offs in other outcomes. Not because it's broken, but because that's how systems work. Now ask yourself something simple. When you choose food, what are you actually choosing? A product or a process? Because at this scale, those two things are the same. You're not just choosing fish, meat, plant-based. You're choosing an environment, a production method, a system of decisions that happen long before the product reached you. Now here's where the shift happens. Because most people don't need to become experts in agriculture or microbiology or supply chains. That's not the point. The point is awareness, understanding that the system is more complex than it appears. That natural doesn't always mean simple. That process doesn't always mean unsafe, but that every category carries assumptions, and those assumptions are not always explained. Now bring it back to where we started. A store, a shelf, a label, and a decision that feels simple. But behind that decision is a system most people never see. Now, the final question is not which food is perfect, because no system is perfect. The real question is, do you understand the system well enough to question the assumptions you've been given? Because once you start asking that, everything changes. Not because the food changes, but because your relationship with it does. And that's where the story actually ends. Not with an answer, but with a shift from assumption to awareness. What's on your plate is one example. There are dozens more, and we're just getting started. Subscribe to this channel because the next story is already waiting.